Good morning and welcome everyone to the technical session of International Online Conference on Science, Technology and Innovation for Sustainable Food System. Today, our keynote speakers of this session are Dr. Uday Annapure, Professor and Head of the Department of Food Engineering and Technology, ICT Mumbai, and Dr. Pitam Chandra, former Director at Central Institute of Food Engineering, ICAR, Bhopal. We are privileged and grateful by your presence to enlighten us on various aspects of food products and processing technology. Food processing implies to whichever system that brings out a modification in raw food or semi-furnished food for nutritious and healthy consumption. India is the world's second largest producer of India and has the potential of being the biggest with the food and agriculture sector. The total food production in India is likely to double in the next 10 years, and there is an opportunity for large investments in food and food processing technologies, skills, and equipment, especially in the areas of canning, dairy and food processing, packaging, frozen food, and thermoprocessing, with a various important subsectors of food processing industries. And consumer foods is another rapidly rising segment of this industry which has gained vast popularity. Though there are many promising dynamics which support good health for this industry, there are still some significant constraints which, if is not addressed properly, can impede the growth prospects of food processing industry in India. The few of the major constrictions is pertain to maintaining the standards of quality, a poor infrastructure for storage, poor quality standards and control methods for implementing the quality standards for processing and packaging the processed foods. Unless these important curtailments are addressed, it will be difficult to break the cultural barrier which people and make it possible to maintain a nutritious and safe food for the millions of people that inhabit both urban and rural areas. Now, the keynote speaker will present our lecture with few of those approaches. One of our keynote speaker of this technical session is Dr. Uday Annapure. Dr. Uday Annapure is a professional and head of the Department of Food Engineering and Technology, ICT Mumbai, with 20 years teaching and research experience. He is the president, designated Association of Food Scientists and Technologists, Mysore. He was awarded Boy Scout Fellowship from Department of Science and Technology, Government of India to visit Washington State University and University of California during the year 2010 to 2011. He has received ICT AFST Best Teacher Award in 2014 and 2016. He was a fellow of Maharashtra Academy of Science in 2018. The research areas he has contributed include cold plasma processing, extrusion processing, plant gums and hydrocolloids, plant proteins, traditional foods, food biotechnology, and bioprocessing. He is also a member of committees for Food Safety and Standards Authority of India and Bureau of Indian Standards, Food and Drug Administration. Thank you. Now, I would like to invite Dr. Uday Annapure to present a lecture on the topic of cold plasma and emerging technology for sustainable food system. So, please. So, unmute yourself, sir.
Okay.
You're not able to hear.
Sure. Okay. Thank you. Thank you very much for the introduction. And, I will share my screen. Is it visible?
Yes, sir. Yes.
Yeah. Okay. Good afternoon to all. And this is an I'm thankful to the organizers for giving me this opportunity to interact with the renowned scientists, students, and faculty members in the fraternity of food, science, and technology. Today, I will be uh, speaking about the cold plasma processing, which is a non-thermal process. Cold plasma as an emerging technology for sustainable food systems. So as we know, the previous speaker have already briefed about the some of the non-thermal processes, uh, and out of that, the cold plasma is one of the process which is coming up in a big way as a non-thermal process. And uh, there are lot many advantages for these processes because basically the non-thermal processes are being accepted nowadays or they are in demand just because to overcome some of the drawbacks in the thermal processing. In general, in case of thermal processing, we all know that many times there are some of the undesirable changes do take place, as well as uh, losses of the nutrients are also there in the thermal processing. And we used to compromise to all those things because there is no any other way as of today. But non-thermal processes may have the some of the upper hand on this thermal processing, where it is possible to protect some of the nutrients which may otherwise be lost during the thermal processing. Of course, any method will have some of the advantages, some of the disadvantages, because as every coin has two sides, so obviously it will be there. But looking at some of the advantages, definitely we can take over cold plasma as one of the good processes for the sustainability of the foods in the coming years. So, as we know that plasma is actually the fourth state of matter, basically, because we know there are three states of matter: solid, liquid, and gas. Plasma, though it is actually the gaseous state, but it has been given a special status as a fourth state of matter because it doesn't obey the laws for the gases. And the reason behind that is that when it is a plasma condition is there, usually you can find the dissociation of the gas molecules into different fractions such as positive ions, negative ions, electrons, metastables, atoms, free radicals, photons, likewise. So it is basically a dissociation of the gas which usually happens during the state of the plasma. In general, if you see, the 99% of the universe is actually in a plasma state. Only 1% of the universe is that what we are experiencing, the atmospheric air and atmospheric pressure and all those gases are there. But rest of the thing, most of the places, the universe, in the universe, we experience the plasma conditions. It means that whatever the uh, gas molecules are there which are in a dissociated form. Rather precisely, I can say those are actually in the state of ionized form. It is an basically ionization is the major concern. It is a major principle by which the plasma chemistry works. So ionization is the most important step in the plasma chemistry, where the gaseous molecules which are there can get dissociated, maybe with the help of high voltage, particularly which can apply at the laboratory. Otherwise, and naturally, if you see the sun is actually in a plasma state. It is an the surrounding atmosphere is actually already in the form of ionization. So likewise, but the when it is but the energy which is coming out of that is very high. So definitely we can't use that kind of plasma condition for food processing, and therefore we have opted for the plasma which is actually in a cold condition. Cold condition means it's not in cold condition. Actually speaking, the plasma is a very hot always, but the plasma which has been developed in the laboratory is generally at the room temperature. And that's what it is called as a cold as compared to regular plasma. It is cold. It cold means it doesn't it is not having a sub-zero temperature or any kind of lower temperature or refrigerated temperature basically. It's at room temperature. That's why it is called as a cold plasma. The ionization of neutral ground state atoms molecules by the electron and all is the common for for production of the plasma conditions at the laboratory. And this is the basis. Ionization is the basis for the mechanism. So if you look at the basic principles of the plasma generation, is like you need the high voltage, maybe the alternative or direct electric current, discharge, microwave, heat, light, magnetic field, or radio frequency. These are the different things which can be used for along with the high voltage for generation of the plasma. Once the plasma is generated, then that generation of plasma means actually it is a gas which is there present in the surrounding of this high voltage uh, field is will undergo the ionization where you can find the different molecules. So after ionization, actually you will get the plasma condition, which is actually the mixture of gas molecules, atoms, charged ions, free radicals, free electrons, ozone, elemental oxygen, and many things. So that's what it is actually the in the ionized phase. And being an ionized phase, all the molecules which are present in this thing are actually in an excited state. And that excited state can be utilized by the uh, by us to change the surfaces of the matter. Basically, the plasma is nothing but an like device or the way by which we can modify the surface of the certain matters, and that is the one which we are actually focusing while using in the food processing. So after ionization, there are different delivery mechanisms are also involved into that. Maybe the discharge, which we call as a corona discharge or atmospheric plasma jet or pulse plasma or microplasma or nanopulse plasma. It's all depend on the requirement of the plasma on the matter which you are looking for the processing. So if you see, look at the this slide where you can see the when we go for the cold plasma, basically we have the different ions, electrons, reactive species, and the UV radiation, some visible lights, electromagnetic fields are also developed during this process. So it's a combination of all these things, but amongst that, the free radicals and the ions are the most important from the point of view of food processing, because those are actually having the applications in food processing, but as well as some other processes also. These are the major one which gives. So in this, if you see this, the working principle of the plasma, where you have these two electrodes. It is a ground electrode and this is a another electrode where the current is being supplied, and between these two electrodes whatever the gas is being field, that will undergo the ionization, and this ionized gas will be carried out as a plasma, and it can be uh, used to expose the different matters which of our interest. So when we have started the work on the cold plasma long back in 2012, uh, we were not having even the equipment uh, for the generation of the plasma. So this is the one equipment which you are seeing at this moment is the in-house. Uh, we have developed it in our physics laboratory at ICT Mumbai, where Professor Deshmukh, who is from the physics department, is involved in development of this particular assembly, which can generate the cold plasma. So you can see these are the two electrodes, top and bottom electrode, and where in between whatever the glow you can see is actually the plasma generated. Whenever there is a generation of plasma, you can see this kind of glow, pink glow. So this is the plasma generation. But while we have started working with this particular equipment which we have developed, but slowly we came to know that there are some of the limitations of this equipment because the gap between these two electrodes is very small, and we cannot put the larger size material. And secondly, when we put the material, only the outer surface of the material is being exposed to the plasma condition, whereas the bottom of that particular material, which is uh, based on the base plate, is not getting exposed to that conditions. And so then we have tried to work on then another kind of thing where we can get an uh, rotating plasma, which is a 360-degree rotating. This is the particular chamber which rotates continuously, so that the material which is present in this particular chamber will be having exposure to the plasma condition uh, throughout, as it is rotating in a 360-degree continuous rotation. And that is the reason we have again developed this kind of equipment with the help of the Ministry of Food Processing Industries. They have supported this project for the development of this kind of equipment, and we have successfully developed this equipment where efficiency is quite more, so that all the 100% surface can be actually exposed to the plasma conditions. So then again, there are certain limitations with these things also, rotating plasma, and as the capacity is small, so then we have now procured, this is an imported equipment, we have procured it uh, where you can see these are the pin reactors where a lot of pins are there, and these are the plasma which is being generated. This pink color glow you can see is the plasma generated. So here actually the you can see the distance is very good, where you can put even the sample of the size of apple or pear. So that is what we required for the food samples actually. Then coming to next is the we have the again the plasma actuated water system, where the plasma actuated water is also important for processing, and it also helps in changing or the modifying some of the certain characteristics of the materials. In a broad sense, if you see the applications of the cold plasma is being usually applied in various, have the good applications in various fields, particularly in the medicine, where wound healing, sterilization, and dental plaque treatment, where the the plasma can be used. Usually, these doctors are having the plasma torch, and that torch is nothing but the beam which comes out is in the form of the plasma, and which can really uh, uh, important from the treatment point of view in the dental plaques particularly. Then for water treatment, again, plasma can be used. Here, actually, in water treatment, you can use hot plasma also if required, because it's not mandatory that you should have the cold plasma only. But in medicine, when it is a dental plaque and all, you definitely have to have the cold plasma because it will not generate any kind of heat, so patient will be comfortable while treating. But in case of water treatment, you can even use the hot plasma if required, and that is quite effective for decontamination, then pesticide degradation, and sometimes the degradation of dyes also, which may be are some of times are the pollutants in the water. In polymers science, the plasma is being commonly used for the surface modification of the polymeric films. Here, particularly, the polymeric films are being treated with the plasma with corona discharge so that printability of this polymeric film can be enhanced. Basically, polymeric film films are very smooth on their surface, and uh, when you go for the printing on that, there is it has been found that there is a poor adhesion between the printing ink and the polymer film surface, and after some time, that ink which has been printed there get peeled off because of the poor adhesion. So that plasma treatment is being applied to the polymeric films where the surface of that film is scratched, and this scratching is nothing but because of the ions and the reactive species which are generated during the plasma conditions, because those are in an excited state and they are totally uh, unstable, and because of that instability, actually they want to get stabilized. Whatever comes in their way, they get attached with that and want to stabilize it, and in that process actually the you can find the fine scratches on the surfaces, and those fine scratches on polymeric surfaces particularly help in uh, proper adhesion of the ink with the polymeric film, and hence uh, the proper printing can happen. So again, surface functionalization and sterilization are the one of the two ways by which polymer science is also having a lot of applications for the cold plasma. Sometimes hot plasma also can be used for the polymeric films and all as per requirement. Now, coming to the food science, now worldwide scientists are working in this area on the cold plasma, application of the cold plasma in the food processing. Uh, the basically all these efforts are being taken all over the world is for the decontamination of the surfaces, or particularly the mycotoxins, fungal toxins, then enzyme inactivation and degradation of the pesticide residues. These are the some of the major areas where scientists are working throughout the world. Now, in case of decontamination, it can be used for even the bacteria and yeast and also it can be used so that killing of the microorganisms, or it may be sterilization, can be possible with the cold plasma. The enzyme inactivation is one of the major concern for food processing, which we usually inactivate the enzyme by the way of blanching and all. So probably the here also um, enzymes can be inactivated with the help of the cold plasma processing. So in a wide range, if you see there are lot many applications where the cold plasma can work very effectively are cereals and pulse industries, fruit and vegetable industry, dairy industry, meat and poultry industry, spice industry, biopolymers, and agriculture, particularly the post-harvest storage and all, where you can avoid the fungal decontamination, and all fungal contamination can be avoided. We have recently completed one Indo-Sri Lanka project, which is sponsored by DST, and which was basically focused on the decontamination of the spices, because uh, we know that all the spices are known for the having the antibacterial activities, but still our target was not on bacteria, but our target was basically the fungus. So though these spices are having the antibacterial activity, but they may have the problem of the fungal growth. So we have actually targeted the decontamination of the fungus or the mold on the surface of the spices. So, so this surface modification is the most important factor in the cold plasma, because in cold plasma, the surface modification is the basic principle which can be applied in the food processing, because here most of the time we want to modify the surface. So in the surface modification, actually plasma is well known, cold plasma is actually well known to modify the some of the properties, particularly the hydrophilicity of the material can be increased, even though material is slightly hydrophobic, but because of the cold plasma treatment, material can be converted into hydrophilic. So hydrophilicity is actually increased due to the this kind of surface treatments. It's hydrophilicity increase means actually there is a modification of surface in a way of the scratching. Surface is getting scratched, and in that process, the hydrophilicity of the material or any kind of film can be increased. That is the well proven system which has been scientists have already studied. So here, modification of the surface is the basic principle for most of the things, where whether it is a microorganism or enzymes or any other material in case of food system. So here, if you see the effect on the microorganism, basically when the microorganisms are being exposed to the plasma conditions, uh, the most important is the membrane, outer membrane of the cell actually comes in contact with the plasma conditions. And as these plasma atmosphere are having the capacity to scratch the surface, definitely they scratch the membranes also. And scratching of the membrane mostly leads to the deformation and leakage of the microbial genetic materials. There are chances at the for the lipid oxidation, especially from the cell membrane, because we know the cell membranes are made up of the lipids. Then cell wall rupture can also happen due to the certain electrostatic forces during the process, and protein denaturation and oxidation of amino acids and nucleic acids are also the possibilities, and which may lead to the death of the microorganisms. So this is an pictorial uh, view how the what is the mechanism is that this is the plasma generation where free radicals and other things are UV radiation and all are there, and which actually are acting on the surface of the membrane, and it is getting damaged. So inactivation process happens because of the damage to the membrane as well as the genetic material. Particularly in case of bacteria, if you look at the gram positive and gram negative bacteria, of course, due to the structure of the bacterial cell itself is a different, and hence the cold plasma will also shown the reaction with these membranes in a different manner. So in case of gram negative bacteria, it is very easy to break the outer cell membrane of the cell, and leakage can happen possibly very easily. But it's not the case for the gram positive bacteria, because the membrane is quite intact, and but at the same time, due to the plasma conditions, the penetration and all, usually there is no cell leakage, but the damage to the internal organs like DNA and all can happen because of these plasma conditions. Even in case of fungus also, the microbial inactivation is possible with the help of cold plasma and the cell apoptosis and fragmentation and other things are there which are actually responsible for all these things. Recently, few scientists all over world are also working on the use of the cold plasma as a mutagenic agent because we know that there are physical and chemical mutagens which are there which are responsible for the mutation in the microbial cells and all. So cold plasma can also be used as a mutagenic agent and the more advantageous is that these are the clean source because there is no chemicals, there is no physical mutation occurs. Then the targeted action through the carrier gas, maybe you can use you can select the gas also, whether you want the inert gas or atmospheric air, or particularly in the gases, whether you want to argon or nitrogen. No byproduct generation and no risk to the personal who is working. That is the major concern in the cold plasma. Enzyme inactivation is also possible with the help of cold plasma is basically due to the changes in the primary and secondary structures of the material of any proteins. It can affect the amino acid sequence as well as the beta sheets in the proteins. And hence it also affects the tertiary structure of the protein. And all the enzymes are basically the proteins, so definitely they can have the some type of blockages at the active site of the enzyme, and which may be blocked and enzyme can be inactivated with the help of the reactive species which are generated during the cold plasma conditions. So, in case of the biological implications of the cold plasma treatment, we need to see that upgradation or downgradation of the specific enzymes can be possible. Induction of the pathways associated with the conversion of simple sugar during the ethanol fermentation in the microorganism, particularly Saccharomyces cerevisiae and all other organisms which are used in the fermentation are also here important. The plasma treatment can markedly reduce the log phase. That is also another advantage. Increase the specific growth rate of the cells, shorten the exponential phase. These are all the results which the scientists are presently working on in the area of cold plasma, along with the effect of cold plasma on the fermentation processes. So, effect of cold plasma on microbial fermentation is under studies, and people have studied the Saccharomyces cerevisiae as a candidate, and it can be seen that uh, this treatment have actually resulted in improved conversion of glucose to ethanol. So ultimately, the ethanol production has been shown to be increased with the help of the cold plasma. I will just go through that. Is so the exposure of Saccharomyces cerevisiae to air, atmospheric cold plasma would increase the cytoplasmic free calcium ions also concentration by the improving the cell membrane potential. A lot many things are there when we need to study the detail the biochemical pathway which is involved into production of glucose to ethanol, conversion of glucose to ethanol. So it is useful in the fermentation processes also. I will just run quick through. Uh, and it helped in case of the wine making also because see the next diagram where you can get a very clear idea that here this is the plasma flow and this is the wine where plasma is actually coming into contact at the surface of the wine and it is getting uh, treated with the cold plasma. But in other case, the wine itself has been passed through the plasma flow, so that there is a chances for the more exposure of the wine molecules in the wine can happen during the processing. And this actually helped in increase in some of the phenolic compounds. That's what is being actually reported. And same thing with the green tea also, and other teas where uh, there is a significant reduction of the E. coli and coliform cells from the green tea, and as well as the decontamination of mold and yeast is possible due to these cold plasma treatments. These are some of the results which are obtained by the scientists. So, coming to the conclusion of this talk today, the plasma is definitely an emerging technology used for the surface decontamination of various agriculture produces, foodstuffs, packaging materials, and many other uh, ingredients. We can say like starches, gums, and other many other polysaccharides can also be. Even the protein molecules are can be modified uh, with the help of the cold plasma. Then effect of cold plasma on the microorganism and the enzymes still need to be understood in a better way, because still work is going on in that direction, and definitely it is an effective tool for food sustainability systems in near future. So with this, thank you very much. I'm thankful to the organizers for giving me this opportunity, and I'm happy to take any questions if there are.
Yes, sir. If anybody are interested to ask some questions to the sir, you can ask.
From the participants, if anyone is having any question. Sir, basically, I have a question.
Yeah, please.
Sir, you have shown in one figure that plasma treatment we are applying on wine.
Yeah.
So wine is basically in that also there are microbes and there are some of the bacteria which is good for the wine making. So how come we can justify that the plasma treatment is not affecting that my particular microorganism?
No, no, no. Actually, what happens when we, in the process of wine making, we add the Saccharomyces cerevisiae for the fermentation process, and then actually we want to stop the fermentation at certain level. We cannot uh, allow the fermentation to be exceeded. Otherwise, it will change the quality of the wine. So in that case, actually, this would be helpful to stop the, sometimes we call it as secondary fermentation. The secondary fermentation may be avoided with the help of cold plasma treatment. And it all depends on what is the voltage and intensity is for the cold plasma which is generated. If, and accordingly that we can definitely restrict the intensity of the plasma condition. Here actually they have used the cold plasma for improvement of the phenolic compounds. And in wine, actually phenolic compounds are the most important, because wine is preferred because of those phenolic compounds and antioxidants which are present in the wine. And it is for the protection of those. That was the major concern of this experiment. And probably uh, also it may help in avoiding the secondary fermentation during the storage. That may be the reason, I can say.
Thank you, sir. Sir, one student is having another question, sir.
Yeah, please.
Sir, in one slide, you have described about 360 degrees rotating plasma generator.
Hmm.
Sir, which kind of food products can be, uh, I mean, which can be applied to get plasma generators, right?
Yeah, in 360 actually you can use the grains and some powdered food products where you can really have the better exposure to all the particles which are coming into contact with the plasma. That is the reason, basically. Otherwise, when it is in static mode, usually the part which where the these grains are being placed on the plate or any kind of platform, the lower side of that grain is not getting exposed to the plasma condition where those are attached to that particular platform. And the advantage of this 360 rotating is that it can all the surfaces, 100% surface area can be exposed with the plasma conditions. Particularly the grains and powdered samples, it is very much useful.
Thank you, sir.
Yeah.
Thank you, sir. Is anybody is interested to ask any questions? You can. Thank you. Thank you, sir, for your magnificent presentation. We really acknowledge you taking out time for us from your busy schedule. It was always been delightful to have you with us. We look forward to your esteemed presence again for the upcoming programs. Thank you, sir.
It's my pleasure. Thank you very much.
Thank you, sir. Now, the other keynote speaker is Dr. Pitam Chandra. Dr. Pitam Chandra, an agricultural engineer, earned his Doctor of Philosophy from Cornell University in USA and Master of Science from University of Manitoba in Canada. He is a graduate from G.B. Punt University of Agriculture and Technology, Patna. He was director of ICA, Central Institute of Agricultural Engineering, Bhopal during the year 2009 to 2014. He participated actively in the planning and first nationwide assessment of post-harvest losses in India. He has been a proponent of taking agri-food processing to production catchments and setting up of machinery customs, hiring units in villages. He has served on various committees of Planning Commission, Ministry of Farmer Welfare and Agriculture, Ministry of Food Processing Industries, Food Education Council, DST, Bureau of Indian Standards, FSSI, and QCI. He is fellow of Institution of Engineers and Indian Society of Agricultural Engineers. Thank you. Now I would like to invite Dr. Pitam Chandra to present a lecture on the automation in agro-processing sector. Sir, please.
Thank you very much. Am I audible?
Yes, sir.
Thank you. So I'll now go to my transparencies. So I'm sharing my screen. Good afternoon.
Good afternoon, sir.
All the officers of the host institution and the enlightened audience. It's a great pleasure for me to be with you this afternoon to share with you some of my ideas about food processing sector. As we know, everyone here is what we consume in terms of food. But then there's a dilemma. Are we eating what we need to eat? And that's where we get into problems. In fact, the food processing sector itself is vulnerable. The success of this sector depends on the quality of the raw materials, and then it depends on the expectations of the consumers. So both on the supply side and the demand side, there are vulnerabilities, and this is what I am concerned today. Let me talk about some of the recent studies, and the observations are that the current agricultural production fails to provide the matrix of foods needed for the world population to have the type of balanced diet recommended by the nutritionists. And a lot of the ills of the present day are heaped on the food processing sector, whether it is obesity or it is cardiovascular diseases. Now, rectifying this imbalance has been reason to save arable land. Almost 50% of the land is arable today, and if we continue with the same kind of situation, we need much more land to produce food. But the idea is that if we rectify this imbalance in the diets and food, then we can meet the requirements. At the same time, we won't need any additional arable land. Require more reliance on plant-based sources of protein. This is important because we lose a lot of resources in raising animals and then utilizing the protein produced by these animals. The data suggests that adopting nutritionally balanced diets should help to ensure sustainable and balanced diets, reduce global greenhouse gases, support ecosystem services and biodiversity, and improve human health. Now, sustainably feeding the next generation is essentially the grand challenge that we all face today. Global agricultural system currently overproduces grains, fats, and sugars, while production of fruits and vegetables and protein is not sufficient to meet the nutritional needs of the current population. Produce and consume more fruits and vegetables, as well as choose diets higher in plant-based proteins. That is the recommendations today. In fact, if you look at the present scenario, the sugar, all that we produce is superfluous. We don't really need any additional sugar. As far as milk and milk products are concerned, we are probably okay. We are producing as much as we need to consume. Proteins, we need much more, but then we are not producing enough, and so there is a shortfall. Oils and fats, we are overproducing. This is the global scenario. Sometimes you may get carried away with the national scenario where we have less of oils and fats produced in the country. But globally, we are producing more and we don't need all that. Vegetables and fruits, we certainly need much more production than what we are doing today. Whole grains, we are on the surplus side. So as you can see, there's a lot of mismatch between what we are producing and what we need to consume. In fact, if we look at the scenario of 2050, when we would all be 9.8 billion, we don't need any increase in the whole grains globally. But fruits and vegetables, we need to increase 8.72% per annum. Oils, we don't need any increase. Proteins, we need to increase by 3.27% per year. Milk or dairy, just a little bit of increase is sufficient, and sugar, no increase needed. This imbalance which really causes our health problems. And that's why we are not eating what we need to eat. And therefore, we tend to go towards the medical sector to correct these ailments. This is one of the slides, and we call it Harvard recipe, health eating plate. And as you can see in the center, major portion is devoted to the vegetables and fruits, just about a quarter to the whole grains and healthy proteins. We need a little bit of healthy oils, but plenty of fluids, including water, tea, coffee, drinks. But this is what we need to see, that there's no specific requirement of oils here. And we need to cut down on sugars or sugary drinks. If we talk about the food composition of the future, as Dr. Anand Ramakrishnan was talking a few minutes ago, food will be tailored to your genome. Now, with the power of the IoT, it's possible to look at each individual and tailor or customize the diets. Emerging field of personalized nutrition has plenty to offer in terms of maintaining our health. Food will be engineered to be more nutritious. Food will be different from anything that you have been eating so far. Food will be guilt-free. And you know what I mean here. Food will be more creative. So this is what we look at for the future of the food for ourselves. If we look at the sustainable health diets, it will be based on a great variety of unprocessed and minimally processed foods, balanced across food groups, while restricting highly processed food and drink products. These foods should be more accessible and desirable, contain minimal levels of pathogen, toxins, and other agents that can cause foodborne diseases. The food should be consistent with WHO guidelines to reduce the risk of diet-related non-communicable diseases and ensure health and well-being for the general population. They should also permit us to maintain greenhouse gas emissions at a low level, water and land use to be reduced, and fertilizer applications and chemical pollution should be under check. Preserve biodiversity, including that of crops, livestock, forest-derived foods, and aquatic genetic resources. Ultimately, we should avoid adverse gender-related impacts, especially with regard to time allocation, that's buying and preparing food, water, and fuel acquisition. These sustainable, healthy diets, they promote individuals' health and well-being. I'll be coming to this top word well-being a little later. Have low environmental pressure and impact, accessible, affordable, safe, and equitable food. Food should be culturally acceptable. Preventing all forms of malnutrition, whether it is undernutrition, micronutrient deficiency, overnutrition, or obesity causing foods. Reduce the risk of diet-related NCDs and preservation of biodiversity and planetary health. So therefore, we have to look at many more things than what we are doing today in terms of food processing. And that's what I am worried about. Now let's realize that about 50% of the globe's vegetated land is dedicated to agriculture. And about 30% of this cropland is used to grow grains for animal feed. Given how much land it takes to grow food for feed livestock, meat production is a leading cause of deforestation and requirement of additional area. In fact, World Resource Institute finds that if current dietary patterns continue, an additional 593 million hectares, which is almost twice the size of India, would be needed to feed the projected 9.8 billion people. Right now, agriculture generates an estimated 25% of annual greenhouse gas emissions, and that is when you combine food production and the land use changes associated with farming, such as clearing vegetation and plowing. If current trends continue, both agricultural productivity, it does not go beyond 2010 levels, then WRI report concludes that most of the globe's remaining forest would need to be cleared to feed the world, and that is going to be disastrous. And the globe would exceed the greenhouse gas emission targets set by the Paris Climate Agreement. There's another estimate about the meat eating habits, that if people in the US and other heavy meat eating countries reduce their consumption of beef and other meat from ruminants to about 1.5 burgers per person per week, it would nearly eliminate the need for additional agricultural expansion and associated deforestation, even in a world with 10 billion people. So that means we would not require those additional 600 million hectares of land under production. Looking at the other part of the food production, that is the post-harvest sector, up to 1.3 billion tons of food is estimated to be lost and wasted annually, which is equivalent to 24% of all food calories produced for human consumption. In terms of economic value, the losses constitute about 14%. And recall that malnourished population in the world also constitutes about 14%. So the scenario is very clear that losses on the farm, as storage and handling account for more than 520 million tons. Losses while primary products are being processed, stored and handled in supermarkets and households, they amount to 780 million tons, making up a total of 1.3 billion tons. To increase food availability, food loss and waste reduction is far more efficient than expanding food production. It is time that national policy accords greater emphasis to post-harvest sector and subsequently to the food processing sector. Looking at India, at present we lose about 100,000 crore worth of food production annually as harvest and post-harvest loss. And if 50% of this loss could be prevented, you can imagine that 50,000 crore of Indian rupees going to the farmers of India and certainly leading to the doubling of their income. Indian food sector has the strong foundation of at least 5,000 years of rich heritage in the form of traditional ethnic foods that are based on local raw food materials. They're nutritious and healthier. These traditional Indian foods suit the Indian population well, leading to the minimization of medical costs, improved health, and national progress. Novelties of Indian food are getting accepted worldwide, thus creating greater potential for the growth of Indian food sector. In fact, turmeric milk, rasam, they are all getting so popular throughout the world in view of their functionality towards human health and wellness. Nearly every process of food preparation reduces the amount of nutrients in foods. That's another important thing that we need to realize. Processes that expose foods to high levels of heat, light, and oxygen, they cause the greatest nutrient loss. Nutrients can also be washed out of the foods by fluids that are introduced during a cooking process. For example, boiling potatoes can cause much of the potatoes B and C vitamins to migrate to the boiling water. And during the process of freezing, drying, cooking, and draining, the losses of vitamins and minerals could be as high as 70%. Although cooking improves digestion and the absorption of many nutrients, the levels of some vitamins and minerals may decrease. Water-based cooking methods cause the greatest losses of water-soluble vitamins. In 21st century, the food production accounts for the use of 50% and 70% of land and freshwater resources, respectively, at the global level, and that poses a great challenge. Social, demographic, and economic factors are contributing to changing lifestyles and eating patterns, and subsequently putting pressure on resources for food production. Unhealthy diets, identified as the second leading risk factor for deaths and disability adjusted life years globally, they account for approximately 11 million deaths and 255 million disability adjusted life years in 2017. And you can imagine how colossal this loss is. Two major challenges of our times are malnutrition in all its forms and the degradation of environmental and natural resources. Number of the undernourished has been slowly increasing for several years in a row, and at the same time, the number of overweight and obese people all over the world is increasing at an alarming rate. In fact, more than 820 million people sleep hungry every night, and 1.3 billion people experience food insecurity, at least at moderate level. Overweight and obesity and their associated non-communicable diseases are contributing to more than 4 million deaths globally. Today, 2 billion adults and over 40 million children under 5 are overweight. Over 670 million adults and 120 million teens are obese. These are all serious concerns and which could be corrected through food. Poor diets are a major contributing factor to the rising levels of malnutrition. Unhealthy diets and malnutrition are among the top 10 risk factors contributing to the global burden of disease. So we need to improve agriculture. We must select commodities to meet the nutritional needs, as was the first postulation when I began my presentation. Enhance farm productivity and income. We need policies to do this. We need supply chains, high levels of processing, value addition, storage, transportation. We need food safety and nutrition in the context of obesity, type 2 diabetes, cardiovascular diseases, dementia, stroke, cancer, hunger, poverty, and all other kinds of ailments. We need to reduce water land use. We need to increase byproduct utilization. Natural resources and environmental stewardship is required, and we need to reduce greenhouse gases, global climate change, and depleted soils. Since food influences human body, mind, and soul, there's a need for food education to necessarily reflect the wholesomeness in terms of the human wellness. This in turn requires that the food education must link food production, processing, nutrition, and consumption, leading to human wellness while adequately rewarding all the players in the food chain. Sustainability of the food system requires optimal use of natural resources and minimization of non-usable byproducts. In fact, if we talk about the food production, processing, nutrition, and wellness, all are the components of food value chain. Food needs to be produced through good agricultural practices. It is then suitably processed using good manufacturing practices and ensuring food safety to facilitate preservation, trade, and consumption. The food must ultimately meet the human, physical, mental, and spiritual needs. Food produced and processed must satisfy the human nutritional needs for a healthier and happier society in a sustainable manner. Now, what is this nexus between food production, processing, nutrition, and wellness? We have seen that there's at present a disconnect between what we produce, what we process, what the human nutrition requirements are, and whether we are achieving the wellness. As a result, the food is produced, then processed in a sexual way. It does not meet the human nutritional needs, and therefore it leads to malnutrition, substantial medical costs, and social distortions. The present policies for agriculture, food processing, human nutrition, and health are not convergent. And the food value chain needs to be better understood and managed so that all human beings are enlightened about production, processing, nutritional needs, and wellness. We know that the human population is expected to increase by a further 2.8 billion by the year 2050, making up a total of 9.8 billion. And the use of resources must be more efficient and new. More sustainable solutions, products, and business models must be developed. People in some parts of the world are starving, while the amount of food that is thrown away globally is colossal, as we have seen from the data. Increasing human population and high prevalence of lifestyle-related diseases impose a huge demand for nutritious and healthy food. Everyone should have the right to sufficient, healthy, and safe food. Global sustainability goals concern the food production and aim at eliminating hunger, securing access to food, achieving improved nutrition, promoting sustainable farming, and reducing food waste. So that there are two ends of the food health spectrum, excess food and inadequate food. 75% of the healthcare spending for chronic diseases is preventable through nutritious and healthier food. High priority research and outreach in food nutrition, quality, safety, and access in relation to food health is required. Food and health literacy is very much required so that the consumers can select the right foods. Sustainable food production requires environmental, economic, and social parameters to be considered, and the policy research linking food production, processing, and nutrition is needed. Nutrient losses occur in the preparation of cooking phases, as I highlighted a few slides back. How and why these losses occur can help the consumer and food processor limit losses and enhance the nutritional quality of the food. Knowledge of how the foods are prepared and how different methods of preparation affect the nutritional quality of the food is extremely relevant for today's consumer. Interventions in agriculture are essential to improve human nutrition. But we need multi-sectoral coordination among agencies with adequate authority and resources in the implementation of government strategies to sustainably reduce levels of undernutrition. Public resource allocation to agriculture and food processing sectors may be made contingent on how much the sector has contributed and plans to contribute to attainment of broader development objectives such as eradication of hunger and malnutrition. The nutrition objective of agricultural planning provides a more holistic vision of what is needed across various ministries to sustainably improve the nutrition. Now, coming to the human wellness, which is the ultimate target of food, it includes physical, psychological, emotional, social, intellectual, and spiritual dimensions of human being. And high level of wellness is the balance among all these sectoral balances. Wellness, in fact, wellness is a concept towards optimal health and where body, mind, and spirit are integrated by the individual to live more fully within the human and natural community. Health is a state of being, whereas wellness is the process of being. Wellness is more than the absence of diseases, and in a holistic perspective, it represents the positive state of being. And that's what we are trying to see through better utilization of food. As far as the goals of agricultural progress are concerned, we should increase food production and processing by themselves. And it is not sufficient unless hunger and malnutrition are addressed. By targeting nutrition through agriculture and food processing, the country is benefited by better income to farmers, reduction in post-harvest losses, greater environmental sustainability, and healthier human population. Incorporation of health and nutrition into the design and conduct of food systems is essential for sustainability of food production, processing, nutrition, health continuum. In fact, we need a systems approach to understand and shape food and nutrition security and nutrition sensitive agriculture. We need to reduce food losses and food wastages. Farmers need to be enlightened to produce sufficient, culturally acceptable, affordable, and healthy food for everyone. Food processing is a crucial interface between producers and consumers. Science and policies are necessary to fully harness the potential of processing for nutritious and safe food. All stakeholders need to be enlightened about what healthy foods and diets are and how these relate to food production and processing. Nutrition sensitive food systems should include agricultural production, food processing, and in particular health and sustainability. We need to re-engineer the food education to create the enlightened human resource. We need to ensure the affordable and desirable foods for a sustainable healthy diet. We need to promote capacity development strategies for behavioral change. We need to quantify and balance the potential trade-offs and develop national food-based dietary guidelines, promote healthy thinking. We must systematically bring to light the multiple connections between different health impacts, between human health and ecosystem health, between food health, poverty and climate change, and between social and environmental sustainability. Only when health risks are viewed in their entirety across the food system and on a global scale can we adequately assess the priorities, risks, and trade-offs underpinning our food system. The provisions of low-cost food versus the systematic poverty conditions faced by small-scale farmers and food workers, and the environmental fallout of the industrial model. Let me conclude by saying that food production must be geared to meet the composition of sustainable, healthy diets, and only then we can be sure that we are eating what we need to eat. Responsible food production systems, including good agricultural practices, must be designed and promoted so that the food processing industries get the right quality of the raw materials in adequate quantity. Food losses and wastages need to be minimized, as the first speaker, Dr. Hindi Vasudeva indicated in his address. Food processing must be seen not in isolation but as a part of the food continuum. Processing must maintain the wholesomeness of the food and lead to sustainable healthy diets with added dimensions of longer shelf life, affordability, and sustainability. Food trade must adopt all technologies to maintain both quality and quality. People, I mean consumers, need to be educated about the role of food for health and wellness. Sustainable healthy diets should be designed in relation to people, their social roles, and their habitat. Human food needs to be harmonized with the food for all other life forms on the earth for sustainability. And education at primary, secondary, and advanced levels is the driver for the knowledge dissemination related to food continuum. So this is all I wanted to share with you, and thank you very much for this opportunity.
Thank you, sir. If anybody having any questions, you can ask.
Are there any questions?
Yes, sir. One student is there.
Yes, please, can you speak a little louder?
Sir, transformation of from animal-based food to protein-based food will reduce various issues like deforestation and loss of food, sir. But in India, is it possible to happen transformation from animal to plant-based food?
No, I'm sorry, I didn't follow because you were speaking too mildly. Can you repeat your question, please?
Sir, transformation of animal-based foods to protein-based foods can reduce loss of food as a feed of livestock and also deforestation. So
Yes.
in India, some plant-based processing units such as Goodot and other companies are introducing, but they are not much successful than Western countries. So, is
Mhm.
it possible to increase the transformation to plant-based protein? I mean, plant-based foods.
Yeah, in fact, have you heard about the Impossible Burger?
Yes, sir.
Yes, so that is one of the indicators how things are going to change in future. We would have more manufactured meat to meet the demands of those people who like animal meat. But then at the same time, we would also have uh, meat for the vegetarian people. So this is something which is happening across the globe now. In India also, some of the people are working in this direction. Very good question.
Thank you, sir.
All right then. I once again thank the organizers for this opportunity.
Thank you, sir. Thank you for your splendid lecture. We are grateful for you taking out time for us. It's always been wonderful to have you with us. We look forward to your venerated presence with hope and great contentment for the upcoming events. Thank you, sir. I would like to thank Dr. Uday Napure and Dr. Pidam Chandra for your valuable time. And now we are ending with this technical session. So finally, we'll be having a conclusion. Uh,
Thank you. I would like to thank all the keynote speakers and all the participants, all the dignitaries present here in the lecture for your valuable time. And I would like to thank all the professors who have given their time for the session. So, with this note, I am going to conclude this session for food processing and products technology. And Thank you both the keynote speaker for their time once again. So this session has been concluded very well, and we have gained so much knowledge about the cold plasma and about the food sustainability and what should we do in the future, what should be our aim being a young scientist, food scientist. So with this, I will like to conclude the session, and we will take a break for 1 hour, and we will start our next technical session from 2 o'clock onwards. Thank you once again.